Alright, in order to solve this equation, we have to combine the two logs. And before we combine two logs, the coefficients need to be 1s. So the first thing we'll do is use property 3 in order to move the 2 to the exponential spot. So we have logarithm x minus 8 squared base 6 plus the logarithm of 4 base 6 equals 2. So one of the properties of logarithms, property number 3, says when we have a number out front, we can move it to the exponential spot. And property 1 says that when we add logs, we can multiply the 4 and the x minus 8 squared. So we have logarithm of 4 times x minus 8 squared base 6 equals 2. Now that I've used the properties of logarithms to combine the two logs, and we have the equation down to where there's just one log, the next thing we do is put it in exponential form. So I used property number 3 at first, and then I used property number 1 to add the logs. And so now we put it in exponential form, so we have to take the base of the log, that's 6, and it'll be 6 to the second power equals 4 times x minus 8 squared. And now we just finish up this equation. 6 squared is 36. Oops. And then we can divide both sides by 4. Now we can square root both sides. And when we square root both sides, we put plus and minus. The square root of 9 is 3. And then when we're square rooting both sides. The square root of 9 is 3, and the square root and 2 cancel out. So we have x minus 8 equals 3, and x minus 8 equals negative 3. And after adding 8, we get 11. And over here, if we add 8, we get 5. So there's two proposed solutions. Often when solving a log equation, though, and we get two answers, it's sometimes the case that one of them is extraneous. We can't log a negative number. And notice that if I were to take 5 and stick it into the left side of the equation, specifically on the first log, if I plug 5 in there, I'd be logging negative 3, because 5 minus 8 is negative 3. And so 5 is extraneous. We have to discard that solution. And so the only answer is 11. Again, the reason why 5 is extraneous is because it's outside of the domain of the logarithm. When I plug 5 in, I'd be logging a negative number, which we can't do.